How many integer solutions are there to the equation x1 plus x2 plus x3 plus x4 equals 25, where all these xi's, that is x1, x2, x3, x4, lie in the range 0 to 10. None of them exceed 10, but their sum must be equal to 25. Now, how many such solutions are possible? I am going to write C1 as the solutions where x1 is at least 11 and C2 as the solutions where x2 is at least 11, C3 where the solutions where x3 is at least 11 and C4 are the solutions where x4 is at least 11. Now, why did I write just the opposite of the given condition? Well, the reason was stated in the first video itself. Sometimes when we want a particular thing, we should look at what we don't want. And hence, since we want to calculate n of C1 bar, C2 bar, C3 bar, C4 bar, I am going to look at these Ci's. N of C1 states the number of solutions where x1 is at least 11. How many such solutions are possible? Let us see. Before going to n of C1, or n of C2 or n of C3 or n of C4, let me tell what are the total possible solutions. The total possible solutions is, if you remember the sticks and the cups problem following the same logic here, we see that n is 4 here, there are 4 xi's and we have r as 25 here. So it is n plus r minus 1, choose r, which gives 4 plus 25 minus 1, choose 25, which is 28, choose 25. Now, n of C1 happens to be the number of solutions where x1 is at least 11. I can tone down this equation as x1 plus x2 plus x3 plus x4 equals 14. How? I earlier stated that x1 must be at least 11. Now I am going to just remove 11 from both the sides. What does it become? x1 plus x2 plus x3 plus x4 is equal to 14. Earlier, x1 had to take the value 11, 12, 13, so on. Whatever be the possibility, at least 11 it had to take. Now, since I have removed the possibility of 11, it takes the value from 0. Right? Let me enumerate some of them for you. If x1, x2, x3, x4, their sum is 14, and I say that some of the enumerations go like this: 0, 1, 9, 4, or 1, 2, 10 and 1, and so on. It is equivalent to asking x1 plus x2 plus x3 plus x4 should be 25 with x1 at least 11. Now, how many such possibilities are there? Again, following combination with repetitions, it is 4 plus 14 minus 1, choose 14, which is 17, choose 14. N of C1 happens to be 17, choose 14. Don't you think it is the same for N of C2 as well? Because x1 plus x2 plus x3 plus x4 equals 25 with x2 at least 11 is the same as removing 11 from both the sides, right? And making the equation as x1 plus x2 plus x3 plus x4 equals 14. I have toned down the earlier question to this question, and hence it happens to be 17, choose 14, the answer. The same for N of C3 and N of C4 as well. Now, when it comes to N of C1, C2, how do we do it? The solution must have x1 at least 11 and x2 at least 11. We want such solutions, right? Now, x1 plus x2 plus x3 plus x4 equals 25. This can be toned down to the equation x1 plus x2 plus x3 plus x4, removing 22 from RHS, it becomes 3 here, right? How do we need solutions for this equation. Now, if I enumerate the possibilities of solutions for this equation, it happens to be something like this: 1, 1, 1, 0, 1101, 0111, 1011, 2100, 1200 and so on. Now, the possibilities for x1 plus x2 plus x3 plus x4 equals 25 with x1 and x2 at least 11. If I write the possibilities for this, some of them are like this. 11 plus 11 plus 3 plus 0, 11 plus 11 plus 0 plus 3, 12 plus 11 plus 2 plus 0, 12 plus 11 plus 0 plus 2 and so on. Now, there is a proper bijection between the enumerations of this equation and this equation. Let me show you a few of them. 11 will go to 0. So 11 plus 11 plus 3 plus 0 will be mapped to 0, 0 plus 3 plus 0. Now 12 plus 11 plus 2 plus 0 will be mapped to 1 plus 0 plus 2 plus 0 and so on. And hence between all the enumerations of this equation and this equation there is a proper bijection. If you're interested, you can take some pause of like say 10 to 15 minutes, write down all the enumerations of both the equations and you can yourself find out the proper bijection. This can be followed for n of c1 and n of c2 as well. Like for n of ci's, when I tone down the given equation to another equation, I can always give you a bijection between the two equations, the possibilities. There is always a bijection. Like how I stated just now, you can try it out yourself. So, the number of possibilities for x1 plus x2 plus x3 plus x4 equals 3 happens to be 4 plus 3 minus 1, choose 3, which is 6, choose 3. That is 6 into 5 into 4 by 6, which is 20. Right? Now, n of c2, c3 will also be the same. It is 6, choose 3. Why? Because n of c1 plus n of c2 plus, or x1 plus x2 plus x3 plus x4 equals 25 with x2 and x3 being at least 11 is the same as x1 plus x2 plus x3 plus x4 equals 3. Just like the previous one, it is the same equation and hence it is 6 choose 3 for all the 6 possibilities n of c1 c2, n of c2 c3, c3 c1, c1 c4, c2 c4 and c3 c4, right? So all of these are 6 choose 3. Now, what would happen to c1 c2 c3? The number of possibilities of c1 c2 c3 will be, you see, all of these 3 should happen. That is, x1 must be at least 11, x2 must be at least 11 and x3 must be at least 11. Well, will this ever happen? Because the moment I give just 11 as the value to x1, x2 and x3, we get 33 as the answer and I have not even reached x4. And hence, n of c1, c2, c3 is 0. The same holds true for c2, c3, c4, c1, c2, c4 and all of them. N of ci, cj, ck is 0. ijk lying between 1 to 4. Now, if this is 0, what will happen to c1, c2, c3, c4? It is very obvious that they will be 0 as well. You can try it out yourself. So, n of ci, cj, ck, cl is 0 for all ijk, l lying between 1 to 4. So, what is the final answer? We wanted those enumerations or possibilities where xi's lie between 0 to 10. So, the answer is n of c1 bar, c2 bar, c3 bar and c4 bar. If n of ci, cj, ck and n of ci, cj, ck, cl is 0, we need not consider them, right? In the final formula, we need not consider. So, the simplified version goes like this. N of c1 bar, c2 bar, c3 bar, c4 bar is equal to n minus n of c1 plus n of c2 plus n of c3 plus n of c4, which is nothing but s0 minus s1 plus S2. S3 and S4 are 0, so I'm not considering them. Plus S2. S2 is what? N of C1, C2, C2, C3 and so on, right? So now, N is 28, choose 25. All possibilities. That is S0. S1 happens to be 4 times 17, choose 14. Rather, I can tell it as 4 choose 1 times 17 choose 14. And S2 happens to be 4 choose 2 or 6 times 6 choose 3. So the final answer goes like this. 28 choose 25 minus 4 choose 1 into 17 choose 14 plus 4 choose 2 into 6 choose 3.